So 3-2. So 3-2 is basically a continuation of 3-1, except for the way we look at things is going to be a little bit reversed. So let's talk about what that means. So in 3-1, I told you we had parallel lines. Because we had parallel lines, you then knew that corresponding angles were congruent. You knew that alternate interior and alternate exterior angles were congruent. We knew that same side interior and same side exterior angles were supplementary because we had parallel lines. Now, we're not going to know if we have parallel lines. What we are going to have is they're going to give you corresponding angles. Or they're going to give you same side interior, same side exterior angles. And we have to see if they give us parallel lines. So if they give us two corresponding angles and they're congruent, then we know that those lines are parallel. If we have same side interior angles and they add up to equal 180, we know that they're causing those lines to be parallel. So we're going backwards. Now the most important part of this section is we have to use a specific word to go from knowing the angles are like congruent or supplementary to knowing that the lines are parallel. So we don't just say corresponding angles or same side. You'll be saying corresponding angles converse. The converse, that is specifically saying, hey, we know the angles are congruent or supplementary, so we know the lines are parallel. All right? You have to use that to get credit. If you don't, you will not be getting credit. All right. First one, corresponding angles converse. If two lines cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So, this is what's going to happen, all right, in a nutshell. They give us these three lines, all right, two lines and a transversal, and then they're telling me that angle 1 and angle 2 are the same. They're congruent. So, because angle 1 is congruent to angle 2 from the drawing, okay, we can then say that line L is parallel to line M. So knowing about the angles, we can then say something about the lines. All right. Next. Alternate interior angles converse. If two lines are cut by a transversal so that your alternate interior angles are congruent, then the lines are parallel. Okay? So it's the same thing, but we're looking at alternate interior angles. Questions so far? Okay. Let's look at the proof. Now we have to fill this in.
Bless you.
Thank you. All right, what do you think you would do for number 1? They give us the reason, but they didn't give us the statement. Yes.
Right angle 1 is congruent to angle 2.
Excellent. Okay. Now, how do I know angle 1 is congruent to angle 3? Okay.
Vertical angles.
Vertical angle. Definition of vertical angles. All right, so we have the definition of vertical angles. Yeah.
Do we have to write a definition?
Should, because that is the proper way of saying it.
Make his job easier.
Thank you.
How's that? Really make it easier.
How many shirts do you have?
It means you're doing it correctly.
What?
No, it's because like.
All right, next one.
There's a different color every single day.
Angle 3 is congruent to angle 2. How do I go from 1 and 2 to all of a sudden 3?
Corresponding.
Close.
I mean, that's not using how we go from 1 to 2 to 3. It's not exactly a substitution. There's a better one. Transitive property. Huh? How we know transitive? Angle 1. So then we can say these two are congruent. Okay. Now the last one. What's the last one? What's the last one?
Have a good day, guys.
You too? He has to leave that early. Yeah. No, you're 1:30. Yes, Disney.
Line 1 is parallel to line 2.
Line 1 is parallel to line 2. Any questions? L1 is parallel to L2.
Can I leave at 28 so I can go to my locker? No, it's actually true. When we get that lunch box.
Oh,
All right. Same side interior angles. If two lines are cut by a transversal, so that same side interior angles are supplementary. Then the lines are parallel. Okay. All right. Let's give it a try. Yeah. Yeah, it was the first one.
Okay, measurement of angle 1 plus the measurement of angle 3 equals 28.
Excellent, and that's given. Now, how do I go from 1 to 2? Subtraction, excellent. I subtract measure of angle 1 to both sides. Very good. Now, number 3, there is no statement, but they're giving me the reason. The reason is a linear pair postulate. So basically, like definition of a linear pair. Where do we see that in this problem? Angle 3 and angle 1. Now, the way we write that is the measure of angle 3 plus the measure of angle 1 equals 1/8. Okay, that's what a linear pair is really telling me. What's 4? Subtraction. Excellent. What's 5? Transitive. Now, looking at angle 2 and angle 3. We now know that they're equal to each other. How do I know my lines are parallel? What kind of angles are 2 and 3? Corresponding. So it's the corresponding angle converse. Because I know those corresponding angles are equal, I can then say the lines are parallel. Any questions? All right, next. Alternate exterior angles converse. If two lines are cut by a transversal so that alternate exterior angles
Thank you.
are congruent, then the lines are parallel. So the proof is similar to the alternate interior angles converse, except for we would be solving for exterior angles. And theorem 3.8. Same-sided exterior angle converse if two lines are cut by a transversal so that same-side exterior angles are supplementary. Then the lines are parallel. Okay. Question so far? What? I said question so far. And the very last part. Remember, the converse tells us if we know the angles are congruent or supplementary, then we know the lines are parallel. Remember, we have to know the information about the angles first, and then we decide if the lines are parallel. Any questions on this?